Modern attacks exploit permissions more often than they exploit vulnerabilities. Hello everyone, and welcome to the Industrial Security Institute. I'm Andrew Ginter with Waterfall Security Solutions. Today's episode is the first in a series of episodes exploring the top 20 cyber attacks on industrial control systems. Understanding attacks is essential to designing robust defenses. Understanding attacks is the only way to realistically compare and evaluate the strength of security that's offered by different security options within a security posture. This series of episodes is based on a white paper that I wrote a couple of years ago by the same name, The Top 20 Cyber Attacks on Industrial Control Systems. The white paper came from something that I was seeing in the industrial security community. Far too many people seem to be paying far too much attention to vulnerabilities rather than other aspects of security. The calculus, in people's minds seemed to go, if risk is a function of consequence and threat and vulnerability and opportunity, if it's a product of these variables, and I can reduce my vulnerability to zero, then I've reduced risk to zero. I am invulnerable. Quick, patch everything. This is, of course, nonsense. Security updates and patches address known vulnerabilities, not unknown vulnerabilities. Vulnerabilities that we don't know about, but that our enemies may have discovered already and may be using against us. Worse, it's possible to take products, many products, all of which have no known vulnerabilities, zero known vulnerabilities, and combine those products in such a way as to produce a system that has vulnerabilities. Modern attacks exploit permissions more often than they exploit vulnerabilities. Even worse, security updates can be very expensive on industrial networks. Every security update is a change to the code. Every change to the source code is a potential threat to correct, continuous, and efficient operation of the physical industrial process. So we can't just update everything. We have to test these things. We test them a lot. The testing process is expensive. The testing process takes a long time. By the time we're done testing, by the time we apply these security updates, new vulnerabilities have been discovered. And so I wrote this paper because, I thought people are expecting too much from this process. They're not getting the return on investment that they ought to be getting. We are far from invulnerable. Let's look at the problem a different way. In the paper, I describe a representative set of 20 cyber attacks across a wide range of consequence and sophistication. But the attacks alone don't tell us much unless we have a target to apply the attacks to. So let's talk about our target. In this series of episodes, our target is a hypothetical large water treatment plant producing potable water. The plant has a 24/7 operator. The operator operates the entire plant as well as a bunch of remote pumping stations. The plant pushes information out to IT systems so that the business can make intelligent decisions about what's happening in the plant. The plant pushes information through the IT network out to customers. And we're going to evaluate the strength of two different security postures at this plant. Our first security program is vintage 2013. We have somehow managed to apply all of the vintage 2013 security best practice advice to this plant. In spite of how costly and difficult security updates are, we have managed to bring the entire plant completely up to date, all of the remote pumping stations as well. We have deployed antivirus everywhere, on the Windows systems, on the Linux systems, even on the PLCs. We have firewalls and encryption. We have jump hosts and two-factor authentication. We have network intrusion detection, host intrusion detection. We have security monitoring. We have practiced incident response teams. We do everything by the book, vintage 2013 or so. All of the modern security advice talks not just about firewalls, but talks about unidirectional gateways as well. In our second security posture, we make only one change. We replace the firewall at the IT/OT interface with a unidirectional security gateway device. The unidirectional gateway is the only connection between the industrial network and the IT network. So now we have our 20 attacks, we have our targets, we need a ruler. How can we measure each of the attacks against each of the targets? Our ruler is the concept of reliably defeats. A defensive posture reliably defeats an attack if the defensive posture defeats the attack 100.0% of the time. Defeats the attack all of the time. This is a high bar. So for example, password guessing. Does multi-factor authentication as a defense reliably defeat password guessing? The answer is yes, it does. We can guess passwords till the cows come home. If we do not have the fingerprint or the dongle or the iris scan, our guessed passwords do us no good. But wait, you might say. There's ways to get past multi-factor authentication. I could hijack the session. I could steal the dongle. But that's a different attack, isn't it? The attack is password guessing, not session hijacking. We have to use the same set of attacks when we evaluate two security postures. We can't be changing the attack because we don't like the answer that it gives us. So again, multi-factor authentication reliably defeats password guessing. Which brings us to our first attack, an ICS Insider. This is a person we trust. This is a person who has the authority to walk into the plant, unescorted. The person has passwords. The person has permissions. Here's the attack scenario. This person is disgruntled for some reason. They were passed over for a promotion. They are annoyed with their employer for some other reason. They walk into the plant. They walk up to a control system computer. They log in with their password. They give the shutdown command, and the plant shuts down. The sophistication of this attack is low. This individual might have a fairly good understanding of the physical process of treating water, but is unlikely to have any kind of deep understanding about cybersecurity or cyber attack techniques. The consequences are intermediate. These physical processes often take much longer to ramp up than they take to shut down. Worse, if any equipment has been damaged, and equipment damage is fairly common in emergency shutdowns, if equipment's damaged, it may take days or weeks for that part of the physical process to come back into operation. If equipment needs to be replaced, it may take weeks or months. So let's look at our security systems, our security programs. What is there in the 2013 vintage software-based security program that might detect or prevent this attack? Well, we might get an alarm. We might get an alarm in the Security Operations Center saying, hey, the plant is shutting down, but there is no scheduled shutdown. This is unusual. This may be an attack. Well, it's great that we get the alert, but the plant has already shut down. The alert did not prevent the shutdown. There's nothing really in the 2013 posture that can prevent the shutdown. I mean, this technician had permission to shut down the plant. This technician might need routinely to shut down part or all of the plant as part of their maintenance procedures. So no, the 2013 vintage system does not reliably defeat this class of attack. How does the unidirectional security posture fare? Well, it does not reliably defeat this attack either. Why? Well, this technician, this insider, physically walked past the cyber perimeter, walked past the unidirectional gateway, carried the attack information, an account name and password, in their brain past the security perimeter, and applied that attack information directly to an industrial computer. Neither of these security postures reliably defeats this ICS Insider attack. And looking forward, this is the kind of thing we're going to do in every one of the episodes in this series of videos. We will take the attack scenario for that episode and apply it to the two security postures, and we're going to build up a scorecard so that we can see visually the difference in how well the security postures address this standard ruler, the standard set of 20 attacks. That's what I had for you. Thank you for joining us at Waterfall's Industrial Security Institute. And you listen to the end of the episode, do us a favor, give us a like, and subscribe to the series. Thanks very much.